One day, you find yourself at a bustling theme park, surrounded by the sounds of laughter and the scent of popcorn. After scanning the rides, your eyes lock onto the biggest attraction of all, the roller coaster. With a mix of excitement and nerves, you make your way toward it, ready for the thrill. You sit down, buckle in, and the cart starts its slow climb up the towering track. Your heart races with anticipation. Then, without warning, you reach the peak and drop. The coaster speeds down, twisting and turning, the wind rushing past your face as you grip the bar tight. It's so thrilling, it's fast and intense. But, what's really happening behind the scene? How does a roller coaster work? That thrilling ride is powered by something called mechanical energy. It comes in more than one form. And in this video, we'll zoom in on one. Today, let's learn about kinetic energy. So, what exactly is kinetic energy? Kinetic energy is the energy an object has because of its motion. Anytime something moves, whether it's a person running, a car cruising down the road, or a roller coaster speeding down a track, that object has kinetic energy. The faster something moves, or the heavier it is, the more kinetic energy it has. We can describe kinetic energy using the formula kinetic energy is equals to 1/2 times mass times velocity squared, or written as Ke is equals to 1/2 mv squared. This tells us that the mass or m of an object matters. Heavier things have more kinetic energy. The velocity matters even more. Because it is squared, small changes in velocity make a big difference in kinetic energy. Kinetic energy is measured in joules, the unit of energy. To understand more what kinetic energy really is, let's take a look at some real-world examples. Imagine a boy sprinting across an open field on a sunny day. His feet pound the ground, arms pumping, and the wind rushes past him. Because he is in motion, he has kinetic energy, the energy of movement. And the faster he runs, the more kinetic energy he has. Let's say the mass of the boy is 60 kilograms, and he is running with a speed of 10 meters per second. What is the kinetic energy of the boy when he is running? To find his kinetic energy, we can use the formula kinetic energy is equals to 1/2 times mass times velocity squared. So, substituting the values, Ke is equals to 1/2 times 60 kilograms times 10 meters per second squared. And what's his kinetic energy? That's right, it is 3,000 joules. Now, what happens if the boy runs faster? Let's say he speeds up to 20 meters per second. Because speed or velocity is squared in the formula, the increase in kinetic energy is much larger than you might expect. Let's calculate the new kinetic energy of the boy. Substituting in the equation, kinetic energy is equals to 1/2 times 60 kilograms times 20 meters per second squared. And so, his new kinetic energy is 12,000 joules. So, by doubling his speed, the boy's kinetic energy quadruples. Even a small increase in velocity can result in a big jump in kinetic energy. Now, imagine a car driving down a smooth, open highway. The car cruises at a steady speed, and the engine is running smoothly. The car, like the boy in the previous example, also has kinetic energy because it's moving. And just like with the boy, the faster the car goes, the more kinetic energy it has. Now, let's say the car's kinetic energy is 200,000 joules, and it is cruising at a speed of 20 meters per second. What is the mass of the car? To calculate its mass, we can rearrange the kinetic energy formula. Let's start with Ke is equals to 1/2 mv squared. Multiply both sides by 2 to get 2Ke is equals to mv squared. Then, divide both sides by v squared. Rearranging the formula to solve for mass gives us the new equation, mass is equals to 2Ke divided by v squared. We know that Ke is equals to 200,000 joules, and the velocity of the car is 20 meters per second. Now, substituting the values into the equation, mass is equals to 2 times 200,000 joules divided by 20 meters per second squared. And the final answer is 1,000 kilograms. So, the mass of the car is 1,000 kilograms. So, what have we learned today? Remember that kinetic energy is the energy of motion, and the faster an object moves, the more kinetic energy it has. The formula to calculate kinetic energy is given as Ke is equals to 1/2 times mass times velocity squared. Both mass and speed affect how much kinetic energy an object has. And third, in our examples, we saw how a boy running, a car driving, and a roller coaster speeding down a track all have kinetic energy. Remember, every time something moves, it has kinetic energy, whether it's you sprinting across a field or a roller coaster racing down a track. Thanks for watching. Like and subscribe for more videos coming soon. And that's it for today. See you next time and stay curious.